Hello, wonderful physics students. Welcome back. In this video, we're going to go through some simple examples using electric potential and electric potential energy. All right, let's get to it. So in this first example, point A is at an electric potential of 750 volts. Point B is at an electric potential of 950 volts. An electron is observed moving at some speed at point A. When it is observed at point B, will the electron's speed have increased, decreased, or remained the same? Da-da-dum. Okay, so this example is wonderful because you don't need to calculate anything. It's all going from concepts. So as always, the first thing I would suggest that you do is draw a picture. And this picture is pretty simple. You have just point A and you have point B. Now at point A we have 750 volts and at point B we have 950 volts. And our electron, let's see, is a negative charge and it's moving this way. So there's our velocity. Okay, now, this brings up a good point here. We have V for voltage and V for velocity, and that could get really confusing. So what I have done is that I tend to do a cursive V for velocity and a capital V for voltage, sometimes even just doing like this for voltage, or this. But I try to make my cursive V's cursive. Anyway, back to the problem. All right, so, well, the first thing that we could think about is our change in potential. Did our change in potential go up or down? All right, so we go from 750 to 950. So our change of potential increased. So our change of potential is positive. All right, so then, well, potential is in that equation with potential energy. So if you recall, the change in potential energy is equal to, and I'm sorry that thing's on the way, is equal to the charge times the change in potential. All right, so this change of potential is positive right here. We just talked about that. And it's an electron moving, so that's a negative charge. So positive times a negative will make this a negative. All right. So now, if the potential energy went down, kinetic energy is going to go up. It's going to increase. So the change in kinetic energy is positive. So the only way that we can get the change in kinetic energy to be positive with speeds is if we increase our speed. So I already have this circled. There we go. Yay! If you notice, we didn't actually calculate anything. How wonderful is that? Okay, so next slide. What direction is the force on an electron? So we have this object that's, well, it's supposed to be an electron's really big. But anyway, it's negatively charged. Now, if we look, the electric field is going to, I hope you said to the right. Yes, the electric field is going to the right. Electric field always goes from positive to negative, and the field line's already drawn there for you so you can see it. Okay, now for a negative charge, the force is always exactly opposite of that of the electric field. Always, always, without exception. Don't you love physics? Yay! No exceptions. Okay, so which point, A or B, is at the higher electric potential? Now, if you recall from previous, what we talked about in class, the higher electric potential is always, always, always closer to the positive source charge. Okay? Electrons always want to go towards the higher potential or uphill. If we think of higher potential as being uphill, electrons want to go uphill. protons want to go downhill just like most things, like the bowling ball example from the previous video wants to go down to lower potential energy. Electrons want to go towards higher potential. They want to go, anyway, I said it like 3 times. Okay, so electrons want to move uphill. All right, so here's an example. A proton has a velocity of 1 times 10 to the 5th meters per second at point A, and a velocity of 3 times 10 to the 5th meters per second at point B. What is the magnitude of the potential difference? And it even tells you you're looking for a change in V between point A and point B. So I would like you to pause the video and try to solve this on your own first. Okay, welcome back. All right, so as always, let's draw out what's going on. So we have A and we have point B. And it's a proton. So we know a couple things about the proton. We know that the mass of the proton is equal to 1.67 times 10 to the negative 27 kilograms, and that the charge of a proton is the elementary charge, 1.6 times 10 to negative 19 coulombs. Okay, and we know that the velocity at point A, so the velocity is equal to 1 times 10 to the 5th meters per second, and the velocity at point B is equal to 3 times 10 to the 5th meters per second. Now you could think of this, you could put this in context a little bit and think, okay, if this proton was in between parallel plates, it doesn't have to be at all, but it can be. So let's see. With the proton, so with the little positively charged object, would it want to move towards the positive plate or the negative plate? Okay, so the proton wants to move towards the negative, right? And away from a positive. So it gives us some context for this problem. All right, since there's no outside forces, we know that the energy is conserved. So another way of saying conservation of energy is that the electric potential energy, the change in electric potential energy, if that goes down, then the change in kinetic energy is positive. So one change is negative right here, the other change is positive. Okay, so electric potential energy is equal to the test charge times the change in voltage, and this is equal to kinetic energy final minus kinetic energy initial. All right, so negative the charge change in voltage is equal to 1/2 mvf squared minus 1/2 mvi squared. And let's see, let's make sure those are velocities and not voltages. There we go. All right, so now we know, we know the charge here, we know the mass of the proton, we know the final velocity of the proton, we know the mass here, we know the initial velocity here. So you plug and chug, and you put in all the numbers, and you get out negative 417.5 volts. Now up here, we're going from a positive plate to a negative plate. We know that since we're going towards the negative, we're going to be going down in voltage, and that negative's right here, showing us that the change is negative. Yay! Cool. All right. It all works out, and that should be the case for you guys too. So I hope you got this. I hope this helps, and we'll see you in the next video. Bye-bye.